are some definite integrals, which is problem 8 on the practice midterm, or the midterm review. So the first one is the integral from 0 to 1, actually of the first integral from problem 7. So it's the integral from 0 to 1 of 4x to the 7th minus 12x squared plus 8x minus 6. The antiderivative of this is 4x to the 8th over 8, which is x to the 8th over 2. 12x cubed over 3, which is 4x cubed. 8x squared over 2, which is 4x squared. And it's minus 6x. And then just plug in 1 and 0. And 1 and 0 are kind of the best limits of integration ever. Plug in 1 and I get 1 half minus 4 plus 4 minus 6. And I plug in 0, since these are all just powers of x, I do get 0. I need to write this really. So I end up with 1 half minus 6, which is 1 half minus 12 halves, which is negative 11 halves, or negative 5.5. Clearly, most of this function is under the x-axis, so we're getting a negative answer. Here, we don't know how to differentiate this. The idea here is that you're supposed to recognize, oh, y equal to the square root of 81 minus x squared is the top half of a circle of radius 9. Right, I can square both sides. Y squared equals 81 minus x squared plus y squared equals 81. This equation is the circle centered at the origin of radius 9. But if y equals the square root of this, it's only the positive parts, right? Or y has to be positive, so it's the top half. So I'm at the top half of the circle. But I'm only going from 0 to 9, so I'm starting at x equals 0, and I'm only going all the way over to x equals 9. So my area here, which is the integral, right, the integral of a function is the area that's below the function above the x-axis. That's going to be 1/4 of the circle, so it's going to be 1/4 pi times the radius, which is 9 squared. 9 squared is 81, so I get 81 pi over 4. So if you see something like this, where you see a square root of something squared minus x squared, and you don't see anything else, like if there was an x out here, we could do a u substitution, but there isn't. This is what they mean for you to do. All right, here is one that requires a u substitution. We're going to let u equal x cubed minus 1, and du perfectly works out to be 3x squared dx, so this is perfectly my du. So we write my integral as the integral of e to the u du. And personally, I like to change the limits of integration. So if if u equals x cubed minus 1, x equaling 1 means u equals 1 cubed, which is 1 minus 1, which is 0. And if x equals 3, u is going to equal 3 cubed minus 1, which is 26. So I'm going to get, from 0 to 26. So then the integral of e to the u is e to the u, from 0 to 26. And just plug in a e to the 26 minus, and be careful, when you plug in 0 here, you don't just get 0, you get e to the 0, which is 1. So our final answer is e to the 26 minus 1. But I'll also point out you can do this without changing limits of integration. You can instead say, oh, I don't want to do that. I'm going to do the integral, and I'm going to leave those as x equal to 1 and x equal to 3 of e to the u du. And then I'm going to get e to the u from x equals 1 to x equals 3. Again, right? I integrated u to the u, I got e to the u. And then I'm going to plug back in u, which is x cubed minus 1. You get e to the x cubed minus 1 from x equal to 1 to x equal to 3. And then when I plug in 3, I get 27 minus 1, so I get e to the 26 minus 1 minus 1 is e to the 0, which is exactly that. So it's really the same work either way. Alright, last one here, integral from -1 to 2 of the absolute value of 2x minus 2. If you ever have to integrate an absolute value of a linear function, the idea is you want to draw a picture. Because really, this is just triangles. If I graph y equal to the absolute value of 2x minus 2, I know that this has its vertex at x equal to 1, right? So if I think of this as the absolute value of 2 times x minus 1, it's the smallest when x is 1. So when x is 1, it's going to be 0. So I plug in 1, I get 0. And I could plot the rest. I know that when I plug in 2, 2 times 2 is 4, 4 minus 2 is 2. So I end up getting 2. When I plug in -1, -2 minus 2 is -4, the absolute value of -4 is 4. I'm trying to find, right, and we'll keep going. but I only care about finding the area under the curve from -1 to 2. So I'm really looking at this area here. Oh, hey, that's a triangle. I'm looking at this area here. Oh, hey, that's also a triangle. So this first triangle, let's call it A1, has area 1/2 the base. Well, the base is from -1 to 1, so the base is 2. And the height is the height here, which is, if you plug in -1, we saw that we got +4 is the height. So 1/2 times 2 times 4 is just 4. Area 2, that's this here. The base there is 1. It's 1/2 times 1. And the height here, if we plug in 1, we plug in 2, we get 4 minus 2, which is 2. So we end up with 1. So the total area, so the integral from -1 to 2 of the absolute value of 2x minus 2 is 4 plus 1, which is 5. And not that I think Pham is going to ask a question like that, but that is definitely how you would do a question like that.